Hello everyone. In this class, we discuss how to show that root 3 plus root 5 is irrational. So, already it is root 3 plus root 5 is irrational. Then how to prove that? So, we can prove this root 3 plus root 5 is irrational in the contradiction method. That is, let us assume that this root 3 plus root 5 is rational first. So, I am writing proof here. Let us assume that root 3 plus root 5 is rational first. Let us assume that root 3 plus root 5 is rational. So rational number compulsory it is of the form p by q. So that is root 3 plus root 5 is of the form p by q or a by b, anything. Now I am writing here a by b. So now here I am assuming root 3 plus root 5 is rational. Rational means compulsory it is of the form p by q form. So where here a comma b are co-primes. A comma b are co-primes here. Co-primes means the GCD, the HCF of A and B is 1. Except the 1 there is no other common factor. Okay. Now I am doing squaring on both sides. Squaring on both sides. Then we get root 3 plus root 5 whole square is equal to a by b whole square. Now do squaring. So it is of the form a plus b whole square. What is the form of a plus b whole square? A square plus b square plus 2ab. A square means root 3 square. Root 3 square means square root cancel, we get the 3. B square means root 5 square. Square root cancel, we get the 5 plus 2ab. 2 into root 3 into root 5 is equal to a by b whole square means a square by b square. Okay. Now 3 plus 5, 8 plus 2 root 3 5 is 15 is equal to a square by b square. Now this 8 sent to the RHS. That means 2 root 15 is equal to a square by b square minus 8. Now this 2 also send this side. That means before sending the 2, first simplify the RHS. 2 root 15 is equal to a square minus 8 into b square, 8b square by b square. Now I am doing cross multiplication here. Now root 15 is equal to, I am sending this 2 also to this side. That means a square minus 8b square by 2 into b square, 2b square. Up to here, okay. Now we know already root 15 is the irrational number. We know already that one. Root 15 is irrational. But that means root 15 is in the LHS. It is the irrational number. But the total LHS value is in the form of a square minus 8b square by 2b square. That means it is of the form p by q. For any values of a and b, the RHS value is rational. For any integer you can substitute in the place of a and b, the RHS value is rational, but LHS is irrational. So how rational and irrational are equal? It is contradiction. It is wrong. So then why we get wrong here? In the starting we are taking root 3 plus root 5 is the rational. So that assumption is wrong. So it is not rational means compulsory it is called irrational only. So that's why, therefore this is contradiction. This is contradiction to our assumption. This is contradiction to our assumption. What is our assumption? In the starting we are assuming one thing, root 3 plus root 5 is rational. So that is wrong assumption. Why it is wrong assumption? Because of this is contradiction to our assumption. Therefore root 15 is irrational. Therefore root 3 plus root 5 is irrational number only. Okay, so this one no need write down, directly you can write down. This is contradiction to our assumption. Therefore root 3 plus root 5 is irrational number only. So that means here in the LHS root 15 is there, that is the irrational number only, because of 15 is not a perfect square. Okay, but the RHS value we can substitute any integer value in the place of a and b. The RHS must be in rational number only. So rational number, irrational are not equal, so both are always not equal, but here they are equal here. So that's why it is contradiction to our assumption. In the starting we are taking assumption root 3 plus root 5 is rational, so that is wrong assumption. So wrong assumption means what is the correct assumption? Root 3 plus root 5 is rational only. Is it clear? Next, see the next third problem in this exercise only. Third problem, we have to show that 6 plus root 2. We have to show that 6 plus root 2 is irrational. We have to show that 6 plus root 2 is irrational number. For that, same like as the previous problem, let us assume that first of all it is a rational number. So proof, let us assume that let us assume that 6 plus root 2 is rational first. Let us assume that 6 plus root 2 is rational. Rational means compulsory it is of the form p by q. That is 6 plus root 2 is equal to p by q or a by b. You can take any variables where p and q are compulsory, write in this condition, where p and q are co-primes, where p and q are here co-primes. So here no need to do squaring. So if both terms are irrational numbers, then we can do square. But here 6 is a rational, root 2 is a irrational. Send this 6 to the RHS. That means root 2 is equal to p by q minus 6. That is equal to p minus 6 into q, 6q by q. So that is nothing but root 2 is equal to. If we observe here, root 2 is a irrational LHS value. But in the RHS, if we substitute any integer value in the place of p and q, must and should the RHS value is a rational number only. That means for any values, for any integers of p and q, the RHS value is rational. We can substitute any integer value in the place of p and q. The RHS must be rational number only. But LHS irrational. This is contradiction. Both are not equal. So therefore, this is RHS is rational. But here LHS is what here? Irrational. So that means for any integers of p and q, the RHS value is rational. But root 2 is irrational. Therefore, this is contradiction. This is contradiction to our assumption. What is our assumption? In the starting we are taking it is a rational number. So it is not rational. Rational not means compulsory it is a irrational only. So therefore, this is contradiction to our assumption. Therefore, 6 plus root 2 is irrational. Understood? So in the contradiction method, we had to prove it. It's very simple. So understood this one? Same like this, we had to prove the 3 plus 2 root 5. First we had to send 3 to the RHS. After we had to send the 2 also to the RHS. Okay? Is it clear? Okay, right.